Olá, seja bem-vindo ao primeiro programa do Mês da Ciência e Educação 2022 da Fundação Francisco Manuel dos Santos. É um prazer estar consigo para o arranque desta série, uma série que pretende divulgar evidência empírica, isto é, transmitir informação fidedigna à sociedade portuguesa no campo da educação e das ciências exatas. Hoje, para abrir as hostilidades, vamos falar sobre as alterações climáticas, um tema tão importante na nossa sociedade e também para o nosso planeta hoje em dia, e vamos fazê-lo com um perito na matéria. Stephen E. Koonin é ex-subsecretário da Ciência do Departamento de Energia do governo de Barack Obama, ex-chefe de ciência da BP, professor na Universidade de Nova Iorque, autor e conceituado físico também. Temos muitas perguntas para lhe fazer, muitas na ordem sobre a informação que temos concreta relativamente às alterações climáticas, o que é que a ciência nos diz, também o que não nos diz e o que podemos ainda aprender e aprofundar. Perguntas que vamos então fazer durante o próximo programa, falando com Stephen E. Koonin. Vamos ligar a Nova Iorque através das carpintarias de Lázaro aqui em Lisboa. Stephen E. Koonin, I'm going to call you Steve because I've been told that's okay.
That's fine.
There's a lot to discuss, and when it comes to climate change and research that has been done, we can date back to the 19th century. There's a lot of data out there. However, in your recently released book, that'll be published in Portugal soon, called Unsettled, you call attention precisely to what has not been established about climate change. So my first question to you has to be, after more than a century of data gathered, what is it that is still so uncertain according to your point of view?
There are some things that we're quite sure of scientifically. We know that the globe has warmed by about 1.1 degrees since 1900. We know that carbon dioxide in the atmosphere, an important greenhouse gas, has gone up significantly since the beginning of the Industrial Revolution. Most of that increase is due to the burning of fossil fuels. And we also know that that increase, together with aerosols that humans produce, exert a warming influence on the climate. Beyond that, things start to get a bit more uncertain. The key uncertainty is how will the climate respond to that human influence as well as natural influences going forward? And how will that response affect ecosystems and human societies? And of course, what should we do about all of this?
I think it's difficult nowadays to go a week without hearing about the urgency of climate change. I think particularly this summer, I can tell you in Portugal it's been the case with a perceived increase in forest fires. We see news of flooding around the world. We constantly find out about more and more natural disasters that are linked with climate change. At least that's what was blamed in Pakistan recently when they had horrible flooding there that caused many deaths. So what we're talking about here is that these phenomena obviously have been increasing, one could say, or would you say they have not, and it's a case of the media paying more attention to them?
I think it's a combination of the media paying more attention together with a lack of memory on the part of most of us. Let me just give you one example. You mentioned the floods in Pakistan. If you listen to the media, they'll tell you these are the worst floods since 1961. That was 75, 80 years ago. I'm sorry, 60 years ago. But if it happened before and human influences were much smaller 60 years ago, you might ask, can I blame this on human influences? I have to explain what happened in the past if I'm going to firmly attribute this to human influences. More generally, extreme weather events, most of them are not increasing on the multi-decade scale that's important for climate. Hurricanes, droughts, and so on, if you read the UN reports, very little trend in any of those. You can always find around the globe some extreme event somewhere, and the media love to emphasize it. But in fact, when you take the long-term statistics, there's very little going on.
We'll get into the role of the media and information regarding this topic overall a little later, but first, as we set the stage for that more detailed conversation, from a general perspective, Steve, don't we know enough already to know that we need to act, and that acting is important as a human race to save the planet or to preserve the planet?
What we do about all of this is a very complicated issue. The science is foundational, the certainties and uncertainties about a changing climate. But then we have to balance that against the world's growing demand for reliable and affordable energy. And then you have to say, what could we do? And what should we do? And what will we do, of course? And those last considerations involve values. It involves the trade-off between environment and development. It involves intergenerational and north-south equities. And of course, it involves costs and benefits. So saying we know enough to act is really a value judgment rather than a scientific judgment. And that's where it gets complicated.
Okay, but you talk about the role of science in reaching certain conclusions, and would you say that scientists and the scientific community have also ignored some of the information that is uncertain or points to uncertainty in order to support their narrative? What do you contend?
Yeah, I think if you look at most of the scientific research papers, they're quite honest about what we know and what we don't know and the uncertainties. It's when you go through this long chain of information that goes from the research papers to the UN reports, to the summaries of the reports, to the media, to the politicians, that things tend to get distorted, if not completely misrepresented. So most scientists, when you get them in a scientific setting, will be perfectly honest about what's known and what's not known. But when you talk to politicians, of course, they've got a message, and they're probably ignorant of the science anyway, and they will just tell you what it is that they think you need to do you need to do.
Now, I'll be honest with you, Stephen. When I was preparing for this interview, I was a little concerned because knowing how many climate change deniers there are out there, I'm like, oh no, this is going to give everybody some ammunition to go against the need to act to preserve the planet. Do you see this focus on the uncertainty as dangerous for humanity as well?
Well, first of all, everything I've written in the book, or almost everything, 95%, is what is in the official reports. And I have just made that evident to the ordinary reader. Is emphasizing the uncertainties dangerous to the planet? Should I not be doing that? I see the duty of scientists is to bring all of the facts to the table and then let the world make value judgments about what to do. I think that, you keep talking about the need to act. I think the need to act depends very much upon where you sit.
Okay.
If you're in the developed world, 1.5 billion of us, we've got adequate energy and we can afford the extra expense, and it is going to take extra expense to reduce our emissions. But if I'm the 6.5 billion people in the developing world who don't have adequate energy, I think I'm much more concerned about getting that energy than I am about some vague and distant threat of climate change.
Now, you wrote that distinguished climate experts, including some report authors themselves, are embarrassed by some media portrayals of the science, but are unwilling to speak up. What do you think of the way science is portrayed in the media today overall?
Let me talk specifically about climate science.
Yeah.
I believe it is people confuse, or the reporters confuse, weather and climate. Most of the reporting is about weather, which happens every day or every season. as opposed to climate, which is averages over decades. They confuse perfectly natural events by blaming everything on human causes. And they omit context. For example, you can see an article in the UK paper, The Guardian, a year or two ago that said Greenland is melting 6 times faster now than it was in 1990. But, if you look at the full data record, what you see is that it was melting just as fast in 1930 as it is, or as it was a decade ago. And so there's lots of variability and lots of ups and downs. And the media will fasten on the most recent things without giving you the full context. And in fact, Greenland's melting has been slowing down for the last decade, which if it continues, as it probably will, that's going to be some inconvenient problem for those who want to raise alarm.
I mean, there's so many questions, and I have quite a few about this because it's so important to get the story straight and not someone's point of view of the story, but rather the facts. And I think it'd be fair to say, Steve, that we lived in such a polarized world, whether that's politically or from a media perspective, where it's increasingly difficult to tell the difference between fact, opinion, and propaganda, right? So what is key, in your opinion, to get those facts right? And what do you see your role being as part of this conversation? And how do you get people to specifically pay attention to the facts that you have to share?
So the facts are the bedrock, the touchstone of science. We have data. We have about 100 years worth of climate data. Of course, it gets worse as you go back in time. We also have limited data on the oceans. It's getting better, but still only about 15 years worth of data on the oceans, which are really where climate happens. And what I've been doing recently, and I'll do again in an article to be published this week, is simply put the data out there with the references. So official meteorological data, official climate data from the UN, and often with a graph, which is the most convenient way to express data, and let people see for themselves. For example, hurricanes have gone up and down over the last 80, 90 years with no obvious long-term trend in most properties. Just putting that graph up there gets people to see, whoa, wait a second, that's not what I had heard. You give them the references, and then what I hope is that people will start either looking at the data themselves, because it's all out there on the web, or asking harder questions of those who are promoting alarm, either the reporters or some of the scientists.
Okay, I'm going to quote you again. You wrote that projections of future climate and weather events rely on models demonstrably unfit for purpose. Of course, these are models that are published in peer-reviewed scientific journals. How can they not be reliable, and couldn't this affect our trust really in the whole scientific process?
Yeah. So peer review guarantees kind of overall consistency, but it doesn't guarantee correctness. I think that's the first thing to say. Secondly, science is a process, and many of these papers are reporting progress in making better and better models. But you still have to ask, are the models good enough? And the papers themselves, some of the experts say the models are not good enough to make useful projections of what's going to happen. Tim Palmer in the UK, Bjorn Stevens in Germany, where he heads the Max Planck Institute for Meteorology, all say that the models are not fit for purpose.
Because they're outdated, perhaps? Sorry, because they're outdated, perhaps?
No, it's the technical challenges. Okay. The models cut the atmosphere and the ocean into boxes. The state of the art right now is that a box is about 100 kilometers on a side. And when you think about weather phenomena, like the clouds behind me, that happen on much shorter scales, you can't describe those small-scale phenomena with a box that is that large. And so you have to make assumptions, and different modelers make different assumptions, and so they get different answers. the hope is that when computers get powerful enough to be able to use boxes that are, let's say, 1 kilometer, namely 100 times smaller, then we'll start to get more reliable answers for what might happen in the future. But right now, the models are not fit for describing regional phenomena or weather extremes.
Okay. You've also argued that real data on the impacts of climate change, such as on droughts, flooding, heat waves, like we've discussed, are portrayed in an exaggerated fashion. We've touched on that. Besides Pakistan, can you give us any concrete examples when you see this happening in the public sphere and the way that it's also digested by the public itself?
So, we had heat waves in the northwest of the U.S. last summer. And when you look at the actual record-setting data over the last 100 years, you don't see any long-term trends. There were no more records set in recent years than there had been in past years for some 30 or 40 stations in Washington State and Oregon.
Okay.
So again, it's this long-term perspective that is quantitative. It's really important. We have very poor memories. There was, for example, a drought in the U.S. Midwest in 1955. And one of the major magazines in the U.S. at that time said, this drought will be long remembered. Well, I don't think anybody remembers that drought these days. So our memories are short. We need good long-term data. Another example, California and more generally the U.S. Southwest have been drifting into drought over the last 30 years. And you might say, oh my God, it's greenhouse gases and carbon dioxide. But in fact, if you look at the record of drought in the Southwest given by tree rings and river flow, there were major droughts in the 1500s and in the 1100s that were just about as severe as the current one is. Those, of course, were entirely natural because they happened long before human influences were important. And so untangling this natural variability from the response to human influences is a major, major problem in climate science.
Okay. Let's go a little bit from the uncertainties to the certainties, because I want to draw upon your career experience in the field with matters connected with energy, obviously working with the President Barack Obama's administration, working with British Petroleum. So actually being out there and dealing with the subject in a very practical manner. What are the main learnings that you took away, and what is the message about the certainties that you pass on that are important for the public to know?
I think one very important thing is when you think about energy, there's a hierarchy of needs, like Maslow's hierarchy of human needs. We need shelter, we need safety, we need food, water, and so on.
Right.
For energy, first of all, it's reliability. If you don't have a reliable energy system, you're in big trouble. The second is affordability, that the energy costs must not break individual finances. And the third is clean. You can only have clean after you have the other two. And clean both locally in the sense of local pollution and clean in the sense of low emissions or zero emissions of greenhouse gases. And I think the current energy crisis in Europe is reminding people that reliable and affordable are much more important than clean. And if you want reliable and affordable, it's got to be, at the moment, fossil fuels. Natural gas, coal. Coal, of course, has its downsides relative to natural gas and oil. So I think that's one lesson. A second lesson is that energy is not delivered by technologies, but it's delivered by a system. And the generators all have to work together. There needs to be transmission of electricity. The fuel molecules have to work with the vehicles. There has to be a distribution system and so on. And those systems change only on multi-decade scales. It takes a long time to change the energy system, as you look historically. And there are good, simple reasons for that. So, and the third is that if you try to change the system too rapidly, it will be very, very disruptive. And you could degrade reliability and affordability. So I think my message is go slowly, think it through, develop emissions-like technologies, and then introduce them in a gradual way, because in fact, the world is not coming to an end. The impact of several degrees of warming is projected to be economically very small. We should talk about that a bit more. And take the time to do it right, rather than this headlong rush to decarbonize.
So let's talk about that a little bit more, and what it means for the planet to keep getting warmer, and when is it too warm for a large part of the planet to deal with, and what impact that will have on civilization. Also in migration, because we've also seen in several areas of the world people leaving countries and continents that are just not sustainable from an environmental and agricultural standpoint.
Well, let's first of all deal with agriculture, just briefly. Again, looking at the data, global agricultural yields have soared in the last 60 years. They are in many places at record highs. I believe India is seeing a record grain harvest this year. U.S. grain harvest, just again, factors of 2 in the last 60 years. If the climate were really getting bad, we would, or having an impact on those, I think we would see declines, and we don't see that. So we're producing more than enough food to feed the planet. The problem is distribution. The societal institutions that distribute the food are not always working very well for various reasons. I think a lot of the migration we're seeing, certainly from Central America to the U.S., which is a big issue here in the U.S., as you may know, those are political issues and safety issues. It's got nothing to do with the climate. Again, one can go on, but the causation there is pretty feeble, actually. Also, you have to realize that robust societies will adapt very well to the climate. I think about Singapore, which lives in an awfully hot and humid latitude. I think about Israel. There are other societies that manage quite well in extreme circumstances. Think about Canada, northern Canada. People are fine there. It's just a different way of living, and we adapt to that.
I would never want to adapt to life in northern Canada, but yeah, I'm sure the people there, the people there know how to deal with it.
That's right. Well, okay, take Norway, for example, all right? The Norwegians have a wonderful standard of living.
Yeah, they do. They do.
Enabled by fossil fuels.
Yeah. I was just joking, of course, but when you look at the message you were talking about, when you say, we need to go slowly and we need to go carefully, that kind of jars completely with what we hear here constantly, especially from the European Union, when you got to go faster and the switch to renewable energy has to happen now, and the goal for 2030 and the Green Deal. And when you see all of this, and I don't know how much you speak with fellow scientists and colleagues in Europe, how would you qualify the difference in mentality culturally to what happens in the big superpowers? So let's call Europe a superpower, but then US, China, India, South America, and mainly Brazil. How do you qualify different people's outlooks on this topic?
Yeah, so I believe in Europe, without insulting anybody, green has become a core belief, almost a religion. And I believe that belief has been shaken since the beginning of the year by the shortfalls in gas,
right,
and the failure of the energy system in many ways, to the extent that you now see natural gas being classified as green by the European Union, and fission, nuclear reactors, also being classified as worthy of green investment. So whatever the rhetoric is, I think reality is taking over. You see the UK returning to fracking, very likely. And I think some of the countries on the continent will be doing the same. So it is the reality of reliability and affordability that is trumping the green feeling. In the US, I think we are more diverse and more pragmatic in many ways. There are some states like California, New York, which are at the green vanguard. But in California, we're seeing electricity rates soar. We're seeing a mandate to eliminate the sale of internal combustion vehicles by 2035, at the same time as the governor is urging people not to charge from an already strained electrical grid. These realities will eventually catch up, and we will do the right sort of thing. I think that will also, by the way, lead people to question more the representation of the science that is driving these things. If I go to India and China, those countries are energy starved. And together with the African countries, they have, to use an American expression, they've given the finger to the developed world and their urgings to go green, and are just saying, we need to exploit the resources that we have, coal, oil, oil in African's case, and we're just going to get the energy we need. And then maybe in several decades, we'll worry about reducing emissions. And from their point of view, that's a perfectly rational position.
Yeah, because the economics of this, obviously, and here in Europe, a big story all over the continent has also obviously been about the rise in energy prices and dramatic accounts of how people are going to be able to pay for their energy bills. Do you think this also will affect the continent's urge and need to go green, to go full renewable energy conversion?
I think it will temper that urge quite a bit. And I think you're going to see a renewal of fossil fuel extraction on the continent in order to provide that reliability and affordability. The problem currently is not that the continent depended upon fossil fuels. It's that it depended on Russian fossil fuels. And by building more LNG import terminals, and by exploiting their own resources, which are substantial, they're going to fix that.
Okay, so let's play a little bit of predicting the future. And according to the certainties we have and the uncertainties which you've also raised, and the whole spectrum of the scientific data that's available, if we're in 2050 right now, where do you think the planet will be from an energy consumption standpoint, and how will that affect climate change? Or not, and how far are we to some part of the population wanting to seek a better alternative on another planet?
Okay. First of all, by 2050, if development proceeds as expected, again, we're talking about 6.5 billion people growing their energy use, not the developed world, which will be flat, if not slightly declining. We're going to see energy use going up by 50%. And if present trends continue, unless the world enacts policies that force everybody to reduce their emissions, we're going to see a growth in emissions, and we will see a rise in temperature. Best guess is another 0.5 degree, perhaps, from where we are globally. Remember that 0.5 degree is not 0.5 degree everywhere. It's greater toward the poles, less toward the equator. And of course, it's only 0.5 degree. I think emissions will continue. The need for energy trumps the need to reduce emissions in most of the world. We will see, I hope, the development of some technologies and their deployment that will let the developed world reduce their emissions. I think most importantly, that's going to be the electrification of passenger cars, together with a reduction in emissions from the electrical system that provides them that energy. Most of that reduction will come from deploying more wind and solar, but maybe even more importantly, deploying nuclear. Because, in fact, the best way to reduce electrical emissions right now and provide reliability is with nuclear reactors.
And do you think and do you see India and China, with obviously the populations they carry, being part of the solution or the problem?
It depends what you think the problem is. If the problem is lifting people out of poverty and, reducing mortality and improving education, then India and China will be part of the solution. If the problem is reducing greenhouse gas emissions because of some vague, distant catastrophe, then they will not be part of the solution. They're going to continue to emit.
You really think that that strategy will not suffer any drastic changes in the next 30 years? It's just not sustainable for them to do that.
It's not even sustainable. It's to try to improve their situation. Listen, another thing about reducing emissions is important to understand. If you read the official reports and the research literature, even for a warming of 4 degrees, remember the Paris Accord is aiming for 2 degrees or less, the impact on GDP is only a few percent by the end of the century. It is an economic bump in the road. And so when people talk about the climate crisis, I'm really mystified because the reports say almost exactly the opposite, at least for the overall economy.
Okay, Steve, but that's the economic side of the story. What about the quality of life and what we can expect as a human race to be able to deal with that increase in temperature? And when is it just not comfortable for us anymore?
Well, again, let's talk about the planet and the impact of warming. We have seen the planet actually become much greener over the last 40 years. There's more vegetation. And NASA, to cite an official source, attributes that to increase in carbon dioxide. Plants love carbon dioxide. We pump it into greenhouses to make them grow faster. And also the growing seasons have gotten a bit warmer. In terms of quality of life, I think that is much more in the hands of humans than it is in the hands of nature. You could have a perfectly good quality of life in almost any circumstance, and we do that, whether, again, it's in Singapore or northern Canada or Norway or in temperate climates. The dominant attribute of humans is their ability to adapt. Consider, for example, the following data point. Since 1900, the globe has warmed by about 1.1 degrees. During that time, from 1900 till now, the global population went up by 5 times. And despite that, and despite the warming, we've seen the greatest improvement in longevity. In 1900, the average human lived 32 years, and that was it. And today they live 72 years. Nutrition, education, childbirth mortality, you can go on and on. And to think that another 1 degree is going to derail or even reverse that progress just beggars belief. And so this is by no means the end of the world. It's a bump in the road that we will manage. We have far greater issues to deal with as a planet.
I wanted to get your opinion on the advanced bioengineering proposals to deal with carbon dioxide in the atmosphere, whether that's releasing aerosols or capturing CO2. What's your view on that?
I think some of them are relatively benign and will be pursued, although I don't think they'll have much impact at scale. There are about 200 billion tons of carbon that go up and back between the Earth's surface and the atmosphere every year. And humans are adding about 9 billion tons a year to that cycle going up and back by digging the carbon out of the ground. And if we could make small changes in that cycle by making plants a little bit more productive, then we could slow the rise, if not reverse the rise of carbon dioxide. The problem is that needs to happen on a massive scale. We can engineer plants that would do that. There'd be all kinds of other environmental objections, I'm sure. We could also try to suck the carbon dioxide out of the atmosphere chemically and mechanically. But if you think about the scale of what's required and the present costs are probably 5 times too expensive, it becomes daunting. So I think we should be researching those, trying to bring costs down and understanding the collateral impacts, but it's not the time to deploy it at scale at all. The other scheme you mentioned is to deploy aerosols into the stratosphere. I think that's a last-ditch attempt. In the very unlikely event that the climate goes very bad, it would be something to consider. So we need to be able to demonstrate whether it's viable or not, understanding the collateral impacts. But there will be a big debate because for some regions of the world, warming is great. And for other regions, maybe it's not so good. So who gets to decide? So that's more a political problem than a technical or economic problem, but it's probably the showstopper.
Okay. And as we start wrapping up the conversation, really focused on some of the solutions to make sure that the climate change continues to be manageable, is renewable energy. And obviously Portugal has a big interest in this with the location that we have and the availability of sun and wind. So what is the importance over the next decades, you think, of these sources of energy, natural sources of energy?
So they are right now the cheapest way of generating electricity, solar and wind. But generation alone does not make for an electrical system. It is a system. And most important is the consideration of reliability. The sun and wind don't generate all the time, and you need some backup, either in the form of large batteries or pumped hydro or fission or gas with carbon capture and storage. And the problem is that there are some rare periods of up to 2 weeks long where neither the sun nor the wind is generating. The Germans have a name for it. They call it Dunkelflauten, namely cold, still periods. And so you had better have a backup system that's at least as capable as the wind and solar, and therefore it's at least as expensive, if not more expensive. And so suddenly your grid costs have more than doubled. And so I think people can run a high renewable grid, but it's the reliability that everybody forgets about. So I think, we could get to the point where 50, 70% is generated, but it's going to be by wind and solar, but it's going to be expensive.
Yeah, I can imagine so. And finally, when you look at the state of play and the way in which especially the economic forces around the world are converging and negotiating on what the future looks like, are you optimistic or pessimistic when it comes to the climate and how much it's changing, and when is it just too late to do anything about it? And when is that too late? I would say we've got a century to try to significantly reduce emissions. But look, our ability to manage changing climates kind of trumps everything. We talked a little bit before about adaptation over the last century. I think I have great optimism that our children and grandchildren will be at least as capable in responding to a changing climate through adaptation as we have been. And they will gradually work on reducing emissions, but it's going to take, as I said, a century or more, because there are 6.5 billion people who need a lot more energy than they've got right now, and fossil fuels are the most convenient and reliable way for them to get that energy. Finally, if you were around the table with the most powerful and influential leaders on the planet, what would be your advice so that they get it right?
Right. I would say, first of all, you need to cancel the climate crisis. acknowledge that this is an issue and that we need to deal with it, but there is not the all hands on deck urgency because the world has got many, many other problems that you should be focusing on. Second, you need to support continued and improved observations of the climate. It's most important that we continue to watch what's going on. Third is that there is some low-hanging fruit that you can do right now. Reducing methane emissions, leaks in the methane distribution system, continued measured deployment of wind and solar is fine, but we're spending a lot of money on subsidizing wind and solar now when we do not need to be doing that because they're already cheap enough. And then I would say research and development of advanced fission, grid-scale storage, advanced biofuels are important, but hold off on crash deployment. Rather, formulate an integrated plan that takes into account technology development, economics, regulation, behavior, and then deploy it gradually. Because right now, the greatest danger to society is precipitous climate action rather than anything you can imagine from climate change itself.
Stephen E. Koonin, it was an absolute pleasure to have an opportunity to hear your perspective on how all the data needs to be taken into consideration when talking about this topic of climate change. Looking forward to the publishing of your book, Unsettled, here in Portugal, and continued good luck in sharing the knowledge you have and making sure people have the complete pieces of the puzzle that we're building.
Thank you. Great talking with you.
Foi um prazer abrir esta série do Mês da Ciência e Educação da Fundação Francisco Manuel dos Santos com uma conversa tão interessante e original com um especialista nos temas que tudo tem a ver com as alterações climáticas, que apresenta aqui uma narrativa alternativa relativamente à urgência para agirmos imediatamente de forma drástica para salvar o planeta. É uma opinião baseada em factos, é uma opinião baseada em estudos que ajudam a construir depois um puzzle que acaba por ser possivelmente um puzzle mais completo relativamente a esta temática. Foi um prazer ter a oportunidade de estar aqui consigo neste programa. Até breve.